Hey guys, so today we're going to finish talking about Unit 3 transformations, and particularly our non-rate transformation, and today we're going to finish by talking about distortions. So what's a distortion? When you think about the distortion is when you multiply either the x or the y coordinate by different factors. They do not produce similar figures. So I guess one way you can think about it is if you're on Microsoft Word, and you drop a picture, if you drag it left, right, up, or down, you're stretching it, compressing it, etc. That's what a distortion would be, right? It's different from a dilation because a dilation keeps everything in perspective. It keeps everything proportional. And so that's the biggest difference between dilation and distortion. So there's two types of distortion. There's what we call a stretch, right? So if we start here with our picture, right, a stretch can be in two ways. We can stretch it this way, which would say vertical stretch, or we can stretch it this way, which we call horizontal stretch. There's also what we call a compression, right? So here's our picture, and we can do it one of two ways. We can do it compression vertically, right? So this way, or we can do compression horizontally, which would look so, okay? So here are the different kinds of distortions if we put some numbers into it. So I guess one way you can think of it is kind of like the rule, right? So the rule for horizontal stretch, well, let's think about it. If we're talking about horizontal stretch, we're only talking about your x, right? Your x part, because that's what controls your left and your right. So here's your what we call our pre-image, and here's what we have our image. If you notice, our x values kind of got wider, right? So they went further away from each other, and that happens whenever the scale factor that you're multiplying the x by is greater than 1. So kind of how when we talk about dilations and when we have a enlargement or reduction, right? So we were having enlargement, so I'll put it here. Enlargement when your k was greater than 1, and we would have a reduction when k was between 0 and 1. So kind of the same thing applies here. The only difference is now we're looking at each component specifically, right? So only talking about the x. So we have a horizontal compression when your a value or the scale factor is between 0 and 1, and same, we have a vertical stretch, right? Vertical because we're only doing something to the y, right? So my y, and a compression for vertical compression if we're only doing something to the y, and that happens. So we have a vertical stretch when your scale factor is greater than 1. We have a vertical compression when their scale factor is between 0 and 1. So let's look at some examples, okay? So it says quadrilateral. So we have a quadrilateral, not necessarily a square or rectangle, just some kind of quadrilateral. And it says EFG, H. And it has the vertices here, right? Which I wrote them down here for us. It says, what are the coordinates of the vertices of the image of E, F, G, H after the transformation? And then it gives us a rule, right? So we take the first part, our change in x, right? It has a scale factor of 3, which is telling me that I'm gonna have two kinds. I'm doing two things to it, right? I am having a horizontal stretch, and I know it's a stretch because here my a value is greater than 1, and at the same time I'm gonna have a vertical stretch for the same reason, right? My b value is greater than 1, and so to produce this new coordinate, this e prime, f prime, etc., we simply multiply the x with 3. So here we would get -6. For f prime we would get 6. For g prime, sorry, we would also get 6, and then for h prime we would get -6. And as far as the y values go, do we get the new y value by multiplying each y by 2. So we get 4, 4, negative 4, and negative 4 and negative 4. Okay. And so if I were to graph it, that would be the original, which is called the pre-image. And if we were to graph the new coordinates, we would expect them to get bigger, right? To get wider. They get further apart from each other. And so that's what it means to have, in this case, a horizontal and a vertical stretch, right? So it both got bigger this way and that way. Okay. So let's look at the next example. So the next example, they're giving us the two triangles. They're giving us the pre-image and the image. And they're asking us, does this experience a vertical compression or a vertical stretch? And if so, what's the coordinate rule that maps the pre-image to the image? And so one thing we got to realize is the fact that here is the image, is kind of like the final product, and this one is the pre-image. Okay. And so if you notice, one thing we can check is, as far as the x values, did they change at all? Now, if you notice, these match up and these match up. So horizontally, there was nothing done, right? So horizontal, there was nothing done. But vertically, we can see that these y values down here, these y values went there, right? And so, and it didn't get bigger, it got smaller. So in this case, we have a vertical compression, and that's the only thing that's happening, right? And so now to write the rule. So to write the rule, we find the coordinates, right? So we're gonna find the coordinate t. So coordinate t is at 1, 2, 3, negative 3, comma 4, and we're trying to see, how did I get t to t prime? So the coordinate for t prime is still at negative 3, but this time it went to, looks like positive 1. And just for good measures, we're going to do w, or let's do all of them. So s is at negative 3, negative 4, and it goes to s prime, which is at negative 3, negative 1. W went from 1, negative 4, to w prime, which is 1, negative 1. So the goal here is, remember when we were finding k scale factors, it was your new over your old, right? So same process here, right? So here's my new y, here's my old y. So here my factor would be 1 over 4th, right? And it doesn't matter which one we do it, okay? Well, actually it does matter, because we're only talking about a vertical compression. Then we're only worried about the y values, right? Because for the x, we notice there's no change there, right? It's 0, it's the same. As far as the y's, we're doing new over old. So negative 1 over negative 4 still simplifies down to 1/4. Same thing here. So here my rule, right? So my rule would be, you take your original xy, you don't do anything to the x, but the y you're going to multiply by 1/4, right? So here is my rule that I got. That shows me, or that tells me, that I only have a vertical compression. So here's the next problem. So it says, find the vertices of the rectangle RECT after the given transformation. And it wants us to graph the image, right? So first things first is we start with the original, okay? And I graphed it for us. And so what I'm going to do now is I'm going to write the coordinates of each one of these, right? So find the coordinate there, 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 and there, and write it down. So voila, okay? And so it's telling me here, before we even start, this first part, this x part, is telling me I'm going to have a horizontal stretch. And I know it's a horizontal stretch because the scale factor is greater than 1, right? This second part here is telling me that I'm going to have a vertical compression. And I know it's going to have a vertical compression because it's less than 1, right? And so that means that I'm doing something to the x and something to the y, each one separate, right? So for the x, I multiply by 2. Okay, so let's go through and write down our x's first. So that's 4, c prime, that's 4, t prime, that's -4. And it says for every y value, you're going to take half of its value. So half of 6 is 3, and half of -6 is -3. And so the last thing I got to do is go through and plot each one of these points, and I get my new coordinates. And as we can see, it changed in both directions, right? So horizontally, right? Horizontally, it got wider, or there was it was stretched, right? So think of it kind of like a rubber band. We're stretching it sideways, and kind of instead of stretching it vertically, we're kind of putting it together horizontally, right? So it compressed vertically. So here we have another example, and now I know it says in the chat, but I want you to write it in the comments in Schoology, right? So in Schoology, go to Schoology where there's videos at, and then in the comments, that's where I want you to write your answer, okay? So I want you to write the answers for R prime, H prime, O prime, and M prime after the given transformation of each one of these. So go ahead, pause the video, try it, and then resume the video so you can see if you got it right or wrong. Alright, so I hope you actually paused it. So what I'm going to do here is I'm going to rewrite each one of these vertices over, starting with R, which is at -6, -3. Then we have H, which is at -4, 3. O is at 6, 3, and M is at 4, -3. So what this is saying is we're going to have a compression in both directions. We're going to have a compression in horizontally and a vertical compression as well because of the scale factors here. And so all we're doing is multiplying by 1/2 for the x, which gives us -3, -2, 3, and 2. And for the for the y values, we're going to divide by 3. So that gives us -1, 1, 1, and -1. And now if I were to plot these points, you can see that we have indeed both a vertical compression and a horizontal compression, right? So vertical compression, horizontal compression. In other words, it got smaller, right? All right, moving on. So now we have a composite transformation, right, with multiple things. So the first thing is it wants us to reflect over the line x equals -2, and then it wants us to dilate with a scale factor of 3 using this as my center of rotations. So we got quite a bit going on, right? So first things first, I'm going to rewrite these down here. -6, -3, and then we have R, -5, -5. So the first thing is we're going to reflect over the line x equals -2. Now, if we remember correctly, the line x equals 2 is a vertical line, right? -2 there. And so that makes it kind of easy because if we're reflecting over this line, that means the y values are not changing. The only thing that's changing is the x, right? So y value is not changing, which makes it easy because it's going to stay the same, right? So I can go ahead and write down my y values for each one. Now, as far as the x value, I have to figure out, well, what's the distance? Remember, for when we reflect, the coordinates are going to be the same exact distance from your line of reflection, right? So from -4 to -2, that was a difference of 2 units, right? And if we keep going, so it's like, this is what I'm saying. So from -4 to -2, that was 2 units. If I go 2 units over, that puts me at 0, right? And the same with -6. So -6 to -2, that was 4 units. If I keep going in that same direction, 4 units over, that puts me at +2. -5 to -2, that was 3 units. If I go 3 units in that direction, that puts me at +1, right? So now I'm here. So now to get to the final point, we got to do a couple of things, right? We can't just jump straight there. We have to because we're using the center of dilation as -1, -4. Okay, first of all, here my scale factor here is 3, which is telling me that it's going to be the same for both x and y, right? I'm multiplying both x and y with the same number. The hard part here is the going from, we'll call this point P. Well, I already have P. We'll call this point C for center of dilation, right? So we're going to go from point C, which is at -1, -4, to each one of these coordinates, right? So, and I'm going to draw vectors. So C to C prime. So how did I get from -1 to 0? I had to go to the right one. How did I get from -4 to 0? I had to go up 4. And I repeat, from C to Q prime. How did I get from -1 to 2? I went to the right 3. How did I get from -4 to -3? I went up 1. And lastly, from C to R prime, how did I get from -1 to +1? Right 2. From -4 to -5, I went down 1. Became more negative, right? So then from here, I apply the rule. Okay, the rule is we're going to scale by 3. So that means I go in here and multiply each one by a factor of 3, right? And that's how that's going to give me my new vector that's going to tell me how I'm going to get from my center of dilation, which is C, to the final prime, to the final coordinate, right? So multiply each one by 3. So 3 and then 12. C to Q double prime is going to multiply 9 and 3. And then C to R double prime is going to be 6, -3. So what this is telling me is that in order for me to get from my center of dilation, which is here, to P prime, right, it's telling me starting at C, which is my center of dilation, which is -1, -4, you're going to go right 3 units. So if I go right 3 units starting at -1, that puts me at +2. And you're going to go up 12 units starting at -4. So if I go up 12 units starting at -4, that puts me at +8. And I repeat the same process. So starting at C, which is -1, -4, my center of dilation, this says go right 9 units starting at -1, which puts me at +8. Go up 3 units starting at -4 puts me at -1. And I repeat one last time, starting at my center of dilation, which is -1, -4. So this says go right 6 units, puts me at 5. Go down 3 units, starting at -3 puts me at -7. And so these are the coordinates that that I need, right? And so if I were to graph it, this is where I would be at, right? So first, it's a reflection, right? Reflection over the line, x equals -2. And then here's my center of dilation with the vectors drawn to each one, right? Then we apply the rule, and the new vector takes me from P to my P primes. Well, in this case, double primes. So I want you to try this last problem. And again, in the comment section, type in your answer and then pause the video to work on it, and then resume the video to see if you guys got it right. Alright, so I hope you guys actually pause the video. So remember, whenever it's given to this, it says two functions. We'll call it function f, function g. So this is f of g, which means we go this way, right? So this one first. So this first one is telling us we have a dilation with a scale factor of 2. This one says we have a rotation of 180 degrees. Now, there's no other point here, so it's the center, the origin, and the big O represents, again, the origin, right? So let's work it out. So a dilation of each one, so we're going to write it out, 0, 3, m is 3, 4, n is 1, 2. Okay, so the first one is a dilation of 2, which means each one we multiply by 2. So 0, 6, 6, m prime is 6, 8, and prime would be 2, 4. Okay, and then it says a rotation, right? So rotation of 180 degrees. So if we were to rotate 180 degrees, the rule for rotating 180 degrees, doesn't matter if it's clockwise or counterclockwise, is negative x, negative y. So that's going to give us L double prime, which is 0, negative 6, M double prime, negative 6, negative 8, and double prime, which is negative 2, negative 4. Quick summary. We talked about distortions, right? So distortions can be horizontal stretch or compression, and can be a vertical stretch or compression. Okay. What determines whether it's a horizontal stretch or compression? We'll say horizontal stretch would mean that here your A value would be greater than 1. If it's horizontal compression, would mean that your scale factor here would be between 0 and 1. And same for vertical stretch. The only difference is now you're not touching the x, now you're doing stuff to the y. And for vertical stretch, it would be greater than 1. For a vertical compression, it would be between 0 and 1.